Hello, my sweet and precious students. Welcome back. This is going to be, I forgot to write this down, so we're going to do it. Saxon 8-7, lesson 36. If you're following along at home, second edition, math 8-7. We are on page 212. If you're in my class, you need to be using this time to write down your notes in your notes section of your binder. Okay, so let me straighten that guy out. So we're gonna be talking about ratios today. So let me launch right into this. Example number 1, go ahead and write this down. Example number 1 is, in a class, I'm gonna set this right here. In a class of 28 students, there are 12 boys. 28 students, there are 12 boys. So the way that this works is we're gonna be writing these as ratios, and our ratio this time is actually gonna have three sections. We have 12 boys. We don't know how many girls, right? And this is assuming just boys and girls. And then we have a total of 28 total. So do you see we have like a 3-part ratio here instead of a 2-part one? Well, if there's 28, right? That means that there's 16 girls. 16 girls, I'm all paranoid now because it's costing me a fortune in chocolate every time I make a mistake. So I gotta double check on my math. Oof. All right, so what it says is, A, what is the boy-girl ratio? A, the boy-girl ratio is 12 boys to 16 girls. However, folks, we always reduce our fractions, right? Well, we can cut these in half. We get 6/8. We can cut that in half again, and we get 3/4. So for every 3 boys, there are 4 girls. 4 girls. Now, B says, what is the girl-boy ratio? This is for B here. The girl-boy, so we have 16 girls for 12 boys. Again, if we reduce that down, we can divide both by 4. We would end up with equals 4 girls over 3 boys. So we can write our ratios either way. Boy to girl, girl to boy. The words are very important here, folks. The words are very important because that tells us the order that we're going to be in. So make sure that you're getting that correct. Let's look at example number 2. The team won 4/7 of its game and lost the rest. That means 4 out of 7 they won, right? That's total. How many did they lose then? How many did they lose? Well, 4 plus what would give us 7? 3 losses. So the way we would really write this isn't like this. It's kind of out of order. 4 won, 3 lost, 7 total. Okay, so that means what was the team's won-lost ratio? Won-lost ratio. That means we need to put the 1 on top and the lost on bottom. The 1 is 4 and the lost is 3. So that would be the ratio. Okay. So the big thing with ratio, guys, is just making sure that you're putting it in order. And then when we start comparing ratios, those are called proportions. When we start comparing those, it's also important that you make sure that you're comparing top to top, the same thing on the top, same thing on the bottom. All right, so let's talk about, now we're gonna talk about probability, because probability is just ratios. Probability, make sure you're writing this down. Probability is favorable outcomes over total possible outcomes. So it's the favorable outcome over the total possible outcomes. When I say favorable, what I'm meaning there is, looking at this example number 3, it says, in the bag were red marbles and green marbles. If the ratio of red marbles to green marbles was 4:5, what fraction of the marbles was red? Okay, so 4 red to 5 green, that means what's missing in our third tier here is our total. So that's 9 total. So it's asking what fraction of the marbles was red? Well, remember fractions, just like probability, it's part over whole, right? So our part of our bag is 4 red and our whole was 9 total. So it would be 4/9 was the probability there, okay? So let's look at example number 4. And remember, probability, favorable outcome over total possible outcome. Let's look at number 4. A single die is rolled. What is the probability of rolling? So this is example 4. A single die is rolled. What is the probability of rolling a 4? Rolling a 4. Well, again, it's possible or favorable outcomes over total outcomes. When we roll a die, there are 6 sides, right? We have a possibility, and anybody who's played a board game knows this. You have 6 opportunities. So there's 6 total possibilities. Out of those 6, there's only one possibility that you're going to make a 4, because all, like, the sides of the die are 1, 2, 3, 4, 5, 6, right? There's only one of those that's a 4. So it's 1 out of 6 is our probability. For B, this is the same example. For B, the probability of a number greater than 4. Well, remember, we have 1, 2, 3, 4, 5, 6 are our possibilities, right? So for probability, the total possible is 6. Now, a number greater than 4 does not mean that it can't be 4, it can't be 3, it can't be 2, it can't be 1. So it can only be 5 or 6. The opportunity there's only 2 there. Cut those in half, we're going to reduce it, you would get 1/3. So the probability of rolling a number greater than 4 is going to be 1/3. All right, for C, we have greater than 6, a number greater than 6. Again, we have 1, 2, 3, 4, 5, 6. And the total possibility is 6, right? A number greater than 6, well, it can't be 6, can't be 5, 4, 3, 2, 1, 0 possibility, 0 possibility. How about a number less than 7? Number less than 7. Well, guys, everything on that dice is less than 7. So we have 6 possibilities, and no matter what we roll, it's going to be less than 7. So that's a 6 over 6, which equals 1. So the probability of rolling that is going to be 1, which is also 100%, right? If we're converting fractions into percents. All right, let's look at example number 5. All right, the face of the spinner is divided into 5 equal sectors and is numbered as shown. It's gonna look like this guy. Oh, I did dreadful there, you guys. That was terrible. Good thing this isn't art class. All right, if the spinner is spun, what's the probability of the spinner stopping on 3? Again, probability is the favorable outcome over the total. Total possible, oh, whoops, not 6. This time, guys, it's 5. 5, because there's 1, 2, it can land on, it has to land on one of those. So the probability of rolling or spinning a 3, was it a 3? The probability stopping on a 3 is 1. Good, hold on one sec. Okay, sorry about that. Somebody came to my door, so I want to make sure that I didn't leave off. So the possibilities that we have here are 5. And if we roll a 3 or spin a 3, it's only that spot. That's only one favorable outcome. We can't get it from anywhere else. Let's talk about B, not stopping on a 3. Not stopping on a 3. Again, if we have our spinner here, can't believe I have to draw this again. Oh, there we go. 1, 2, 3, 4, 5. Not stopping on a 3 means it would stop here, 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 here. Possibilities, 5. Favorable possibilities, 4 out of those 5. Hopefully that makes sense. Okay, let's see. Okay, so the next one for example 6, this is one is example number 6. We have this spinner, but it's not divided equally. It is divided like this, and it says 1, 2, and 3. The face of a spinner is divided into 1/2 and 2/4 as shown. What is the probability of the spinner stopping on 3? Well, guys, in order for us to figure out the probability here, we actually have to have this evenly divided. So what I'm gonna do is divide this here, okay? That means that a 1 belongs here and a 1 belongs here. So you have double the chances of getting a 1. Out of our opportunities, there are still only 3 probabilities, okay? So what we're gonna do is, there are still only 3 probabilities, but we have to divide that up equally is what I was trying to explain. So there's 1, 2, 3, 4 spots here, and we're going for the spinner stopping on 3, which is right here. That's gonna be 1 possibility out of our 4 possibilities. Now let's talk about 1, right? There's still only 4 possibilities for 1, right? However, there's 2 spots here. So this is for 3, is this guy. There's still only 2, there's 2 possibilities of it landing on 1, so that's 2. Reduce that down, we get 1/2, and that makes sense because 1/2 of our entire circle is 1. All right, guys, what I'm gonna have you do is go ahead and go through those practice problems. Parents, I will email out those answers to you guys so that you have them. If you have any questions in class, actually, what we'll probably do is go over those in class. If you have any questions, let me know. Otherwise, great work.